Welcome to the CLIMAX Academy Live. I'm Jim Miller, the Global Training Manager. Today we're going to be talking about an LM5200. Well, we're having it as our demonstration. We're really talking about milling in general. And we've received a few questions over the Ask CPMT at cpmt.com. And so we thought we'd address those today. We will play a short video today, and then we'll go into our live session. So if you have any questions during that short video or even during the live session, go ahead and type those in at the Zoom Q&A at the bottom of your screen, and we'll get to those at the end. So as always, I like to start off with safety. I want to make sure the floor around me is clear. There's nothing to trip on, no cords, no... We're not going to be running the machine live today, so I don't really need to worry too much about chips or anything like that flying around. But in a normal situation, I would want to be cautious of all of that. So once we're familiar and recognize that I'll be careful handling these cutters because they're sharp. So I'll be using extra care to not just grab things inadvertently because that is a potential cut hazard. But other than that, that's about the most danger that I'll anticipate today. So, okay, so once we're pretty comfortable with our environment and the hazards that we might come in contact with, we can go ahead and proceed. So again, right after the video, we'll open things up for the Q&A. So if you have anything, go ahead and type those in at the Q&A at the bottom of your screen. So okay, I guess let's go ahead and play your video, and then I'll see you right after that.
We were looking for a machine with a profile like this, a small, thin profile that was strong enough to do the boring job and the milling jobs that we need to do.
We did a lot of conversations with customers to see what do you want to see in our new products. And one of the things they mentioned was more flexibility. So we took that back to the design team and did a lot of brainstorming and came up with a machine that has ultra flexibility. You can make it longer or shorter relatively easily, as well as spread it to do more footprint machining, as well as we kept the rigidity.
Some of the things we've liked about this new linear mill are the rigidity and how strong it is. We haven't found anything that it can't do yet. You know, it's pretty easy to set up these configurations. The part is modular, it breaks down, we can get it down into the hold, or we can lift it up with a crane, move it around, level it up. It's really good for setup. We can get the job done in a hurry with this machine. One of the things I really like about this machine is the modularity. We can take this thing and we can change it around in pretty quick order, and it'll do whatever we want to, and it does it really fast.
So one of the advantages with the Gantry is in one setup, you have a huge area you can machine, whereas in the past it might take you multiple setups to do all the work at once. So this really gives somebody a quick way to machine a maximum area. There's nothing out there that'll do what this machine can do. This machine will go on site and do the work that would take many hours and a lot of cost to do. This can do it right on site.
As far as reliability and performance is concerned, when you push the button on this guy, it goes. We've had absolutely no problems with it whatsoever. It does exactly what you tell it to do.
So this is something our customers have asked for. They wanted flexibility, and we gave it to them.
Okay, so that's kind of a quick overview. That little video there kind of shows you the capabilities of the machine. Like I said before, we've had a few questions over time, and I thought we'd just address those. We kind of grouped the milling ones together today. So we'll start out with those questions, and by all means feel free to go to that Q&A at the bottom and type in any questions you might have beyond that. And what I might say might prompt some questions for you, so I'll try to be as thorough as I can. Okay, so John, what do we got for that first question there?
Are there options for me to use other milling tools?
Great question, because the standard LM52 and LM62 come with a face mill. They come with a 4-inch, the 52 4-inch and a 6-inch, and then the LM62 comes with I think it's a 5-inch and an 8-inch. But I wanted these as an example here to show you the difference between a spindle of a LM52 and an LM62. So this is what we refer to as a 50 taper, and there's two different types. You'll see a Cat V option or an NMTB, which is National Machine Tool Builder Standard. So so both the 40 and the 50 come in the NMTB or the Cat V. And let me show you what the difference here. So I've got a 40 NMTB and a Cat V side by side, and you can see the tapers are identical. The tapered portion of the holder, that taper is the same taper, but the difference is this little portion here that the draw bolt threads into. So the draw bolt is actually slightly shorter on an NMTB spindle than it is on a Cat V spindle. But virtually other than that, they're the same. The taper's the same. It's just the length of the draw bolt. So that's the Cat V and the NMTB on the 40. 50 is the same way. Now the other option that we have, or two options on the smaller mill, is what we refer to as a Weldon shank. And what a Weldon shank is just a finely ground ID that's set at a particular diameter. On the key mill it's 5/8, on the PM mills it's 7/8, or 3/4, I'm sorry. And then you can get collet holders for any of the other machines. But the Weldon shank has got two divots in it, and that's so the set screw can hold it so the end mill can't travel axially with the spindle. So the Weldon shank is the other style, and then the HSK is the other. It's a short taper that has a tapered lock on it. So these are the terms you'll come into when you talk about Weldon shank spindle, HSK spindle, 40 taper, NMTB versus Cat V, or 50 taper, NMT versus Cat V. So hopefully that kind of gives you an overview of the different types. Now, as I mentioned, they come with a face mill, but any of these different types of tapers can also use either a collet or a rigidly mounted ID tapered holder or straight holder. So I can run end mills, I can run finishing mills, I can run corn cob end mills, I can use Jacob's chuck, so I can center drill, ream, tap. I mean, anything I can do in the spindle of a stationary mill out in the shop, I can do in the spindle of one of these machines. So hopefully that answers that question. I mean, we get that a lot, that, am I limited to just the face mill that comes with the machine? No. Any tooling that you have in a machine shop that is one of those style of spindles can be used in the spindle of this machine. So kind of a long-winded, hopefully that helps some people.
What is climb milling?
Okay, great question. Climb milling is one we get a lot. There's conventional milling or climb milling. So let's take this end mill, and it's going to be a clockwise rotation cutter, right? This particular cutter is a clockwise rotation. So if I'm rotating this clockwise and I'm feeding it axially, if I'm feeding against the rotation, that's conventional milling. But as I'm rotating, if I feed this direction, the same direction that the cutter's rotating, that's what we refer to as climb milling. So if the cutter is rotating the same direction as the work is passing by it, that's climb milling. And if you're feeding opposite of the rotation of the cutter, that's conventional milling. Great question. Now, normally you run into that when you're doing end milling, but even with a face mill, if I'm only cutting half the width of the face mill and I'm feeding against the rotation, I'm conventional milling. But if I'm feeding the same direction that the cutter's rotating, if I'm less than half the diameter, right, because then I'm only on one of the quadrants of the mill, then I'm climb milling. So it is a standard term that's used in milling or facing, in end milling or facing. So good question. Okay, next question.
What does it mean to tram the spindle?
Great question. We get this a lot. So tramming is basically a term meaning making the spindle perpendicular to the axis. So if I'm tramming for the Y, I'm adjusting the head side to side. And if I'm tramming for the X, I'm adjusting the head front to back. So the way that the LM52 and 62 are designed is I have the ability, there's a center pin in the center of this clamp that clamps it onto the saddle. And the milling head actually has a slight amount of movement, about a 1.5 degree latitude of movement. So that gives me the ability to indicate or perfectly align the spindle to the Y-axis. And there's 2 set screws right on the top of this plate. I would slightly loosen the clamp screws that hold the clamp against the saddle plate. And what I would do is I'd pull this motor off, I'd put an indicator on the spindle so I can rotate it freely by hand. That's why I would pull the motor off. And then I can indicate on the bottom of the rail of the ram. So I can go from side to side and make sure that this is perfectly zero from one side of my Y travel to the other. Then the spindle is trammed perfectly in my Y axis. Now in my X axis, either I can go over the top of the bed and do a front to back, or in most cases I can just check on my workpiece front to back. And then the way I adjust that is I have 4 screws around the perimeter that clamp this to the saddle, and I've got 4 set screws right next to them that push away. So if I need to bring the bottom out, I apply pressure to those set screws and pull this out. And if I need to bring it back, then I make sure these are against it, and then I push these and I can push it the opposite way. So it's a form of indicating the spindle rotation perfectly to the axis. That's what really tramming is. It's kind of a long-winded, or it's a short version of what you're doing in that process. But hopefully that answers your question.
Why would I want gantry milling versus linear milling?
Okay, another great question. It really is application specific. Right now we're set up in linear mode. So what that means is I've got both bed sections clamped together. There actually is a split line down the center of this bed that allows me to bolt these 2 beds together so that I'm a fixed distance between the rails. And then when I assemble the machine, my milling head can cantilever out from one side or the other to the linear bed. Now, that is a perfect application for if I can set the bed right next to something that I need to machine. But there are instances where I don't have enough room to mount off to the side of an object, and I still need to do a milling operation to it. In that case, we have what we call a gantry kit, which allows me to separate these bed sections, and then I can span or have a milling rail on either side of the workpiece and work in between. Now that's a better relationship between the cutter and the support, so I have a little bit more rigidity in my milling if I can span the workpiece and support on both sides of it. But it really just does boil down to what application I'm trying to do, whether I have the room to mount the bed on either side of the workpiece or mount the work on one side of the workpiece. But hopefully that answers the question. There's a ratio that we never want to exceed, and it's in the manual, of how far that spindle can reach from a bed rail unsupported. And so it really does limit my envelope of milling if I can't span and put a rail on either side. Then I have a much smaller envelope between the center line of the spindle and the edge of the bed, and I can virtually double that if I have then it's just the length of my ram that limits my width that I can span over. So hopefully that makes sense.
Can the X and Y axis movement be automated?
Yes, automated meaning controlled by a computer. We have the option. Now that's a custom. We don't have a standard. Programmable XY axis. That would be a custom machine that you could order through your sales territory manager. But these are equipped with a zero backlash ball screw on X and Y. And right now it's a pendant controlled DC feed motor. So I can run the axis independently, remotely from the pendant. Here's the pendant that comes with the machine. So this allows me to select the X, the Y, or the Z axis that I can run remotely. But as far as automatic feed, like a CNC or a PLC control, those would be custom order.
How is the bed fixation done?
Yeah, okay, so the beds are clamped in a couple of different ways. There's a plate that's on the outside of the sections that hold the sections together. When the machine is in linear mode, the two beds are bolted through to each other, and that ties the two bed sections together. On the outside of the machine, pardon my walk around here, on the outside of the machine there's a plate that ties the two end plates together, or the two bed sections together. So the fixation of the beds to themselves they're clamped together by screws. Now then, the bed clamping down to the workpiece, there's holes that are set up all along the perimeter of the beds that clamp the bed to the workpiece, and then also there's a set screw that pushes the bed away, and that's how we can adjust for level. So hopefully that answers that. The beds are clamped together by screws, and then they're clamped down to the workpiece by screws. Oftentimes customers will manufacture what we call a sub plate, which is a continuous plate that goes under the machine, and that allows it to be moved around without having the beds be independent of each other, but that would be something that you would add to it yourself.
Does the spindle use a drawbar similar to a Bridgeport milling machine?
Yes, yeah, so you can see the top of the draw bolt here, and then that draw bolt runs down through the center of the spindle, and that's what actually threads into this. On a 40 taper, it's a 5/8/16, I think, and on the 50, it's a 1" 8. So much bigger draw bolt. But the answer is yes. They're held into the spindle with a draw bolt.
Can we connect a coordinate control for the X, Y, and Z axes?
No, they're independent. They like I said, they all. So this will have a single cable that runs out and runs to the power unit, but I can only select one axis at a time. I can't do a coordinated move where I'm running X and Y. not on a conventional mill. I have to select whether I want to feed the X, the Y, or the Z independently. So good question though. Okay, well it looks like oh, DRO, is that a question? Yeah, there is an option for a DRO, a digital readout is the term for DRO. Now the mill itself comes with a Z-axis linear scale, and what that linear scale is just a digital scale like you'd see on a bore measuring tool or a caliper. It just tells you in thousandths or millimeters, either one, the amount of movement for the Z, and that's mounted right on the side of the machine. But if you were requiring a digital readout for the X and the Y, that could be ordered separately. We do have an option for that. So that would be something you'd contact your area sales manager and ask to get a quote on adding that to your machine.
What is the setup time?
Yeah, boy, that's a tough one. Me not knowing your capabilities, it's almost impossible for me to know how efficient you work, right? And so that's always I can calculate machining time, and I can calculate inches per minute metal removal rate. Those are just math numbers. But as far as efficiency and setup, that's a tough one. If you're taking this out of the box and you're leaving it in linear mode and you're putting it on a work table like this, using a gravity level or a bubble level or precision level to line up the bed and to line up the Y, and then just using an indicator in the spindle to level the machine, that can be a 2-3 hour setup, right? But if you're going into gantry mode and you're vertical setup and you're hanging the rails independently of each other and then mounting the ram, that could be an 8-hour setup, right? So not knowing the application is a major piece that I would be missing on that, as much as what lifting capabilities, what leveling capabilities. There's just no end to the setups that are possible. I mean, we really recommend Brunson Optics for leveling. But if you have the money and you can hire a tracker, a laser tracker to come in and shoot the beds for you, that's probably the most accurate, right? Then again, like I mentioned, the precision level or the bubble level, gravity level, that's a pretty good way to go. I mean, the Egyptians used it, right? Back in the day, water level. So it does the job. But it does add to the time, and it does add to, you have to think ahead a little bit on how you're gonna do that. So I know I didn't really answer your question there, but it can vary from a couple hours to a full day or longer, depending on the complexity of the setup. So
Can the machine be equipped with auto stops in X and Y to prevent crashes?
Yeah, it can. We've found though over time, what we have is what we call a bump stop, and at the end of travel, the way that the feed motors are designed is they will hit the bump stop and stall. It's designed to be able to do that. But as far as setting a stop midway, it's not proven the most practical for most people. It can be added. It's something that you could, again, contact your area sales manager and they could direct you to what it would take to make that happen. But for the most part, when you're milling, you just want to be able to have the full length of travel, and a lot of times those stops are not the best option for people. So we've chosen just to put them on the ends of travel to protect the machine as best we can, and then the intermittent stopping in between, that's kind of up to the operator. Okay, well that was a great session, guys. I really appreciate all the questions that we got, and again, keep them coming. A lot of these questions we had ahead of time, or some we had ahead of time, because we've kind of collected them over time. People have asked specific things. Now, obviously, we did not answer their question and made them wait for this. But we took the questions that we had already answered for people, and we said, hey, you know, we get a lot of these. Maybe there's other people that still have these questions. So hopefully it was helpful. And again, if we missed something and there's something that's just that you really need to know or would like to know from us, go ahead and submit that to the askcpmt@cpmt.com. We'll get you an answer for that. We'll put it on the list, and maybe it'll show up in another one of these videos at some time. So really appreciate your time. Hopefully this is a valuable time for you to spend with us, and we look forward to seeing you next time. Take care.